Nam- So we'll start today in the direction of making most advanced semiconductor chip in India by the indigenous company called Sankhya Technologies from Visakhapatnam. So today we have with us CEO of Sankhya Technologies Visakhapatnam, Shri Gopi Bulusu. Over to Gopi Bulusu, please.
Yeah, Namaskaram. Thank you for inviting me for this presentation. What I am going to speak over the next 10 minutes or so, it is about a platform for system design automation for designing and developing cyber physical systems. The name of the platform is the Terraptor Designer from Sankhya Technologies. So, how do you turn your market idea to the world's most advanced semiconductor chip? We will go through this over the next 10 minutes. So very quickly, let us look at what is this system design automation. Converting a product idea into a product, we can say, is design. And automating design is the technology that helps with the it helps with the simplification of the design process.
So are you thinking about all types of system? It can design any type of system, let us say communication system.
Yes, it is for any cyber physical system design automation. So
any cyber
communication systems also come from design automation. Yes.
So it will start from the chip level.
Including.
Can you just tell what system design means, just to make our audience more educated? What do you mean by system design?
Yeah. So here the basic point we are trying to make is that there is a certain challenge or a problem that people are facing, or a pain point that people have, and so you have a requirement for something, and a system is something that is designed to meet these requirements. So the requirement may be something where user has to, you want to deliver a set of experiences to the user, and through a system. The system could be, for example, an equipment like a mobile phone, or it could be glasses, or any cyber physical system. It could be a robot. It could be a rover that goes around on Moon or Mars. So that is the system we're talking about. It could be an aircraft, right? So if you have a market idea, you have a design which is basically a blueprint for the solution. So that is, creating a design would basically turn the idea into reality.
Okay, please continue.
So for design automation, these are the tools that help automate the process of designing. Creating a design. You have a market idea. You want to convert it into a design so you can actually manufacture the product. Then the set of tools that help you with automating the design process is the design automation. And if you look at the term design flow, which is used a lot, especially in the semiconductor chip design industry, is a series of steps that one goes through to get from the idea to the actual blueprint for the product. So that is a design flow. So system design automation platforms essentially support a design all the way from an initial idea to the creation of the blueprint for the product.
Who are the other companies who also do system design automation? Can you just tell?
Yeah, in this slide, actually, we are not talking about companies or domains or capabilities. We are only talking about system design automation.
Okay, please continue. Yeah.
So we'll move to the next slide. Yeah. So this is just a very quick introduction to system design. So the number of global SDA firms can be counted on fingers. So many of the companies we hear about companies that help automate software development. Right? We hear about companies that automate, say you have these SDKs and IDEs, integrated development environments. There are many companies that everybody knows about, and there are many companies that offer electronic design automation, where you are automating some aspects of the system, mainly the electronics. However, when we're talking about the SDA, system design automation, the scope essentially expands to both the software and the hardware. There are very few true SDA firms in the world today, because it is a very hard thing to do. Creating a system design automation platform means you have to handle multiple kinds of design elements. So companies that have been working for decades often, they only have the ability to automate the system design. That's why we can very confidently say that the best SDA platforms are decades ahead of AI.
So how you think software is also
very,
included? I'll just interrupt. Software is also included in this?
Yeah, because when we talk about a system, it includes everything. Okay. And especially I'll give a very simple example. Let's say someone is creating a next generation telecom broadband solution using a constellation of satellites that are orbiting the Earth. Some companies already do this today, but let's say someone wants to do this in a better way. Now the system is actually everything from the satellites that are orbiting the Earth, the communication routers, the receivers, the transmitters running inside the satellites, the communication that happens between the satellites for routing messages from one part of the world to another part of the world, as well as the communication happening between the satellites and the terminal which is there on the Earth. It could be a handheld terminal, it could be just a mobile phone, or it could be something which is there on as a dish on top of a home, whatever. So this entire thing is a system. So if someone wants to design this system, because one can clearly see that creating a system does not mean making a small chip. It means having something in the example we are talking about, having something orbiting the Earth, then having the equipment inside that, having the user terminal, and the entire design to be, one has to show that the whole process is actually working. So that would be the design. So taking more concrete terms, the processors and the communication, IP which is there in a chip on the satellite, along with the modem, basically the broadband codecs, or these wireless RF elements of the overall system, as well as the on the ground what's going on inside a mobile terminal. So all of this. So we are not talking about any one thing.
Okay, please continue.
If there is an existing standard like 5G, for example, one can then simply design a mobile phone, 5G phone, and expect to work with the existing overall system. But if it is next generation, then it has to work. The entire thing has to be made from scratch. Okay.
Okay, please.
Yeah. So Yeah, that may be a very rare thing, right? I mean, companies designing the entire system, but system can be a complex system. So that's why we use the word complex systems many times. Yeah. So Sankhya Terraptor Designer basically is a platform that helps small design teams turn their market ideas into the most advanced semiconductor chip designs.
So I'll just interrupt.
We can tell about.
I'll just interrupt. Why you call it a terraptor? What is the meaning of terraptor?
Oh, it's a word without any meaning, really. You can think of it having a rhyming with computers and Terra, and it was a product that was named in the 2000s. Yeah.
Okay, please continue.
So it is like a brand name. Yeah, it's a brand name for the product.
Yeah, please continue. So,
Yeah,
Sankhya,
so the
Terraptor
Terraptor.
designer. Yeah, please continue. Yeah.
So if I'll give another example, somebody wants to design a satellite launch vehicle, for example, say there is a 4-stage rocket. One can easily see that each stage will have a control processor, and all the stages, the systems are communicating with each other. So here the system is spread across the stages, which are actually getting ejected after every stage. And the whole system has to work perfectly, all the time, from the time of launch to the time of putting the payload in orbit. So the focus of Terraptor Designer is on the software and hardware elements. It allows abstraction for the physical elements. So it's a complete cyber physical systems modeling and design platform. Yeah, next slide, please. So now I'll list out some of the features of Terraptor. Many of them are very, very unique to Terraptor Designer. Very, very few. In fact, I can say that there may not be any other product in the world which can actually match Terraptor on this rich feature set. Okay, so it is one of the most advanced system design automation platforms in the world. I will briefly explain each of these terms. The design space expansion. If anyone is doing a traditional design process, there is a hardware team, there is a software team, everybody is designing. So the design space is constrained to the individual modules somebody is working on. But with system design automation, the design space is the entire system. Hierarchical language models. A system design where one is creating the overall system model basically is a tree. There is for example, if we take the communication, low Earth orbit communication process we talked about, there is at the highest level, there is the overall system. You go one down level and you have the spacecraft, the communication satellite, and you have the ground terminal, and you go down one more level, you will have the system buses, the chips, and the software running. So you can see that this is a hierarchy. So modeling a hierarchy requires languages to be supported by the design automation platform, which are supported in the case of Terraptor Design.
So what are the type of languages? What are the type of languages that you are talking about?
Yeah, so Sankhya Terraptor supports different types of languages. It supports Sankhya machine description language, which is actually used for modeling of processors. It also uses Sankhya system description language, which is used for hierarchical modeling and system modeling. In addition, one can use traditional languages for software like C, and one can also use the HDLs like VHDL or Verilog for the hardware modeling, the VLSI components, for example. It also supports modeling of the physical elements, abstract modeling using C++. Yeah. And it also allows, distributed system models using IDL. Yeah. In addition to the hierarchical model space, the core models of Terraptor, which are like, for example, the system modeling using SSDL and SMDL, these are very transparent models, which means that the tools which can actually read the models at runtime and understand what they are. So there's a complete separation between the models and the tools. You don't have to rebuild a tool for a particular design. So that is the next line, which says about meta-model driven tools. It is straightforward to do architecture exploration. I mean, how many processors do I need to do this particular problem? Those kinds of things are very easy to do with Terraptor because you can actually run your binaries on the processors and try out various configurations and check if what is the best option for a particular problem. Now, another key aspect of Terraptor is the model system continuum. Today, we hear the word digital twin. Earlier, maybe a decade, 2 decades back, the term virtual prototypes was very popular. So whether it is digital twin or virtual prototype, these refer to essentially a model of something where the model and that something are fundamentally different from each other. They exhibit similar behavior, but they are not made from one another. So the virtual prototype stays a virtual prototype. It doesn't convert into the real thing. Whereas with Terraptor, the models can be synthesized. So you can actually model a processor and synthesize the hardware implementation of the processor. You can model the system and synthesize it. And there are research space, there are languages which Sankhya is working on, like Manifolder, which can be used for synthesizing more complex behavior. So, we refer to this as the model system continuum. The model space explorer is like a generative AI thing, which can look at a processor and say, I will automatically test a processor, right? So the system design automation platform, which as part of Terraptor design, there is also a verification solution which can be used to automate 100% automate processor verification. So when we say very high level synthesis, high level synthesis often refers to going from, in the case of hardware design, chip design, semiconductor chip design, going from HDL to say GDS tool. So we say very high level synthesis because very high level synthesis means your abstractions are much higher level. For example, a processor abstraction can just be say 600 or 700 lines of SMDL. So for a fairly complete 32-bit processor. So very high level synthesis means you're able to turn higher level abstractions into the real designs, which can be used to fabricate the chips or emulate them on an FPGA. The design reuse is obviously once you create a model, you can reuse it. So this is like a very large block reuse. Which is you can mix and match models as you go from one product version to another product version or from one product to another product. I already spoke about Manifolder, the advanced modeling languages we're working. Yeah, next slide, please. So here, this is a chart, everybody wants return on investment. If you are investing on a system design automation platform, what do you get really, right? So if you look at the left side, we talk about the traditional product life cycle or a project life cycle, whatever, right? So you have a description of what you want to do. You develop the hardware. Once you have the first version of the hardware, you start developing the software. And once you have the software done and the hardware done, you integrate them and finally finish it. So there is a overlap, but basically there is a part, there is a time when you are just working on hardware and you're just working on the integration. it takes time. If software takes 2x time, if hardware takes 1x time, and integration takes 2x times, then you end up having 4x time for the overall thing. And some of these can go into a loop, which means you develop the hardware, you develop the software, then you decide that your hardware is not working, so you go back. So in fact, when people are working on chip design, it becomes a loop, really. It may not finish after 4x also. You will have to, many times you have to go back to the drawing board and restart for various reasons. So if you look at the right side, we are talking about system design automation, how system design automation with Sankhya Terraptor, with all the benefits we just described, how it changes things. See, you pretty much start developing the software and the hardware and integrate them at the same time. Now, that is a huge, huge change. So because you are doing everything at the same time, you can see all those outlines which align with the previous slide, previous chart. How much saving is there? You start doing software, you start doing hardware, and you start always by integrating them. This is like the holy grail of agile system design. So you're directly jumping into an agile process, which is supported by a very mature platform. So you create your hardware, which could include processor, one or more processors. You are developing the software, and they're already integrated because you're running your software on the hardware you are modeling. So this is the project lifecycle transformation one can see happen with a system design automation platform like Terraptor Designer. As you can see, it saves on time, it saves on resources. So those who want to be ahead of their competition, or those countries that want to be ahead of their competition, they tend to move to system design automation as a strategy. As a sovereign tech strategy, I can add. Yeah, next slide, please. So is it all theory? Actually, no. Dream Chip Electronics, which is, by the way, a company where I'm also a co-founder, used the Terraptor System Designer and created this entirely new product from scratch. This product includes a processor, a system on chip. It includes an embedded OS, which is a Sankhya Anusthitam, and it includes apps that run on this OS. It includes a completely new 16-bit phonetic code used for supporting Indian languages. So here is a product that was designed using Terraptor Designer. And this product, when you turn it on, it actually boots, and it boots using an operating system which was created exactly for this product and similar products. And it uses a new phonetic code for representing information, which was part of the design processor for the Siddhi SoC. This product uses the Siddhi system on chip, and it uses a synthetic processor, completely automatically generated from the processor model in SMDL using Terraptor, using VHLS or VLHS, the very high level synthesis. And in addition to all these, this is a product which is today somebody can actually buy and use it for studying for 5th class students, Telugu. Other editions are going to be offered, but the product supports Odia, it supports Tamil, the proof of concept, as well as Hindi or the Devanagari. So it's a hugely disruptive product developed using Terraptor Design. And such a product could not have been developed unless you had 200-300 people working for 5-6 years and supported by a huge amount of venture capital. And Dreamchip did this absolutely without any venture capital. In fact, it did not get any funding from anyone for developing this other than from the founders. Yeah.
So this is really a great achievement. I just want
Yeah,
to.
let me add, and also support from Sankhya. Yeah.
So this is a great
S-
achievement, really a great achievement. Yeah, please continue.
Yeah. Dhanyawad. Yeah. Next slide, please.
Get the
So,
last slide.
what I just yeah. So what I just talked about is a complete success story of both a system design automation platform and a actual system developed using the SDA methodology using Terraptor Designer. And one thing I want to say is that Terraptor Designer has been a product created through research and development in India by Sankhya Technologies, and the R&D has happened for almost 28, 29 years, starting from 97, 98. So it's a decades long process. And today, if there is a startup trying to do something in quantum or something in energy, or a new communication device, a robot, just about anything, they can actually take advantage of the availability of such advanced system design automation platforms from India.
So I have some questions for this. So
Yeah.
how do you think this can be used for Sanskrit operating system for Indian languages in the future? Can we have our own operating system like Windows operating system?
See, first thing, Windows as an operating system is hugely successful, whether it is Microsoft Windows or Linux with X Windows. These were designed and developed during times where the user requirements were different, fundamentally different from what they are today. And clearly, the requirements of tomorrow are going to be different from the requirements of today as well. So the kind of multi-modal interactions where devices can basically respond to what people talk, right, means that the user interface is going to be fundamentally different. So the fact that the Terraptor Designer has been used to create Siddhi by Dreamchip, where Dreamchip has a complete development platform available now, thanks to Terraptor Designer and Dreamchip's own work, which is available as reusable models. Definitely, this platform supports creation of next generation operating systems focused on Sanskrit and other Bharatiya Bhasha. So I would say that the very strong foundation, in fact, you can actually say that already there is an operating system supporting Sanskriti code from SCCI. So whether you refer to it as Sanskrit operating system for Indian languages, or the SCCA term for it, which is the SCCA Upameda operating systems, I think it's already there. So, and it can be made even more powerful. Yeah.
So I have another question. So you are actually in Sanskrit, we have Astadhyayi, Panini. So can this support Panini, Astadhyayi to bring up the entire knowledge ecosystem in Indian languages and Sanskrit?
Actually, that's a very good question. See, this is why I was talking about, the systems including everything, right? Why we call it as complex systems. So today, if you see that particular device, the Siddhi device that we have seen, there is also a mobile app that comes with it, where users can download content and download it from the internet and from a Siksha portal, and send it to the device, and then from the device they get access. So the content needs to be obviously be there in all Indian languages, all Bharatiya Bhasha, right? And for that purpose, the core technologies which are part of Terraptor, all of the technical terms I explained a bit earlier in the presentation, they have been condensed and retargeted to support basically Panini inspired or Panini transformers, we call it. See, this is another product line which is available from Sankhya. The Panini transformer technology allows one to create models, right, for building solutions for translating content between Indian languages, as well as generative AI kind of solutions. So that's probably another presentation. Yeah.
So I am actually asking about the security, because now the world is fighting among themselves. Some Israel pagers are busting at some of the locations. So how secure will be your product? Can we make the product fully secure? Because that is the question everybody is asking.
Yeah. So my answer would be that, see, think of Terraptor Designer as a system design automation platform. The system you're designing is in the scope of somebody who wants to design a new product. So security is one of the drivers for creating new systems, right? So if someone says, I want a more secure system, they want to develop a new product for that. Then they need a system design automation platform to accelerate their system design and development. So security is part of the system being designed. So definitely one can design more secure, more powerful, more complex systems using a system design automation platform like Terraptor Designer.
So thank you very much.
I take an example. So I'll just give a quick example. There is a C programming language. Then there are lots of C programs. So the C programming language can be used to develop systems, and you can develop a secure system using C. Sometimes people say, hey, I will use Ada for more secure software development, right? But fundamentally, the security comes from the design, and the ability to design comes from the language.
So thank you very much. So today it was our first session on from you regarding the system design automation. What I want is that to build the indigenous capabilities, we need to connect people like you and so many other people. I am interacting with a lot of engineering colleges and students. I am also involved in different security programs. So I will request you to continue this sessions, discussions henceforward, so that we will connect with all the stakeholders. Just like in a Mobile World Congress, I have seen yesterday, Qualcomm is collaborating with Huawei. So similarly, I want the Sankhya technologies and all the engineering colleges, because we have many engineering colleges and many students are aspiring to do something. Only thing is that they are lost in the Excel sheet. So instead of learning in Excel sheet and this IIT joint entrance examination, I will request you to make a course syllabus with an indigenous system design automation tool that is available with you, and let students do system design and a new way of thinking in Indian languages. So I have only 4 minutes left. So if you want to say something, please, we will conclude after your.
Definitely, we do work with universities and support them in creating curricula. So we can also work with other universities, if you suggest, on various topics of interest for them using system design automation. We'll be happy to do that.
So with this, So I thank you very much for this first session. Thank you.